Hello friends, I am Dr. Sangeeta Patil, Assistant Professor in the Department of Electrical and Electronics Engineering, MIT School of Computing, MIT ADT University. Welcome you all for a course on Basics of Transformer. Let us start the lecture. Students, transformer is a static device without any rotating part which transfers electrical energy from one alternating circuit to another alternating circuit with desired change in voltage or current level but without any change in the frequency. So to explain the definition, on this side I have drawn one diagram. This rectangle represents the transformer to which we are going to give the AC input, and at the output also we are getting the AC output with desired change in voltage or current level but frequency does not changes. Transformers are designed to operate either on single phase supply or three phase supply, and accordingly your transformers are classified into two classes: single phase transformer and three phase transformer. Now let us see the working principle of the transformer. The operation of the transformer is based on principle of the mutual induction between two circuits linked by common magnetic field. To understand the working principle, let us consider the transformer in its elementary form. So this is showing the transformer in the elementary form. It essentially consists of two windings. P is nothing but your primary winding and S is nothing but your secondary winding. And these two windings are wound on a laminated common steel core which is denoted by C here. Okay. So the vertical portion of the core on which these windings are placed are referred as the limb. So this much of portion is nothing but your limb. Okay, and the top and the bottom portion excluding the limbs are called as the yoke. The winding P, which is connected to the existing supply system or which receives the energy from it, is called as the primary winding. So P is nothing but your primary winding. The another winding S, which is delivering energy to the load at the desired voltage, is called as the secondary winding. So S is nothing but the secondary winding. When primary winding is connected to the AC supply, the applied alternating voltage will circulate the alternating current. Let that current is I1. Let that current is I1. This current flowing through the primary winding produces the alternating flux phi. The flux is shown by the dotted line here. Most of this varying flux links with the secondary winding through the iron core C and induces EMF in it in accordance with Faraday's law of electromagnetic induction. This phenomenon, due to which an alternating current in the primary winding produces an EMF in the secondary winding, is known as mutual induction, and the EMF induced in the secondary winding is known as mutually induced EMF or EMF of the mutual induction. The frequency of the EMF induced on the secondary side is same as that of your supply frequency or the supply voltage frequency. Now, if the secondary circuit is closed by means of the load, the mutually induced EMF in the secondary will circulate the current. Let this current is I2 through the load. Thus, the energy is entirely transferred magnetically through the core from the primary circuit to the secondary circuit. Obviously, students, there is one question in your mind. If we, instead of AC supply, if we apply DC supply across the primary winding, what will happen? So student, it should be noted that transformer action is not possible with the direct current of the constant magnitude. Why? Because the flux produced by the direct current is not alternating, but it will be of the constant magnitude. So as there is no change in the flux linkage with the secondary winding, the induced EMF in the secondary winding is equals to 0. And if DC is applied to the primary winding, EMF induced in the secondary winding is 0. then there is possibility of the transformer core saturation. If core saturates, primary will draw excessively very large current. Therefore, application of DC should be avoided in case of the transformer. Another reason of not operating the transformer on DC supply is that the resistance of primary winding, let that resistance of the primary winding is R1. It is very small. It is very small, approximately equals to say it's 0. It will draw very large amount of current from the supply. The excessive current may damage the transformer. Then you can say that with the AC supply, whether the current is large or it is within the range, friends, it is the EMF of the self induction in the primary circuit which limits the current, because according to Lenz's law, this EMF of self induction in the primary is opposing to the applied voltage. So the resultant voltage in the primary circuit is less, and therefore the current drawn at the starting is less. It will not damage the transformer. Now let us see the constructional features of the transformer. As discussed previously, transformer mainly consists of the core and the winding. So first main part of the transformer is laminated steel core. Second, windings. It includes primary as well as secondary windings. But with increase in the size or the capacity of the transformer and the operating voltage, it also needs the other parts such as transformer tank, terminal bushings, conservator. All these parts are shown in the figure. One by one I will explain you. Breather, explosion vent, and Buchholz relay. All these various parts of the transformer are shown in the figure. So let us take the parts one by one. So first important part is nothing but the laminated steel core. The core of the transformer is made up of the magnetic material, and it is used to provide the path of the low reluctance or the path of the opposition for the flux. Lesser the reluctance of the magnetic circuit, stronger will be the field, and more EMF get induced in the primary as well as it will link with the secondary. The material which is actually used for core is nothing but high grade silicon steel. The material which is used for core is nothing but high grade silicon steel, which has two important property. It has high permeability. It has high permeability and low reluctance. So this high grade silicon steel is in the form of the laminations of about 0.35 mm to 0.5 mm thickness. These laminations varnished or coated with the enamel to insulate them from each other. The core is assembled in such a fashion that it provides the continuous magnetic circuit with minimum air gap. Now see students, why we are using the laminated structure. When we are using the solid core, when I am using the solid core, then the area of the cross section will be more, as the flux produced by the current flowing through the primary winding also links with the core, which is a closed structure. it will induces the EMF in the magnetic core also, and that EMF is called as ADEMF. As your core circuit is closed, this ADEMF circulates the AD current in the magnetic core. So if your core is solid, which is having the cross-sectional area more, core is having, if it is made up of the solid material, then it has more cross-sectional area. So A increases means resistance will decrease. A increases means resistance will decrease. Means the opposition provided by your magnetic core to the flow of the AD currents induced in the core will be reduces, and hence AD current loss in the solid core will be more. When we are using the laminated steel core structure, we are reducing the area. If area decreases, then a resistance offered to the flow of the AD current will be increased, and hence AD current loss will be increased. So to reduce the AD current loss, we are using the laminated structure. So main purpose of laminating the magnetic core of the transformer is to reduce the AD current loss, which will take place in the magnetic core of the transformer. So students, this figure A shows the arrangement of the joints in the two adjacent layers of the L-shaped lamination. So this is my one L-shaped lamination, and this one is the second L-shaped lamination. These laminations are staggered properly so that it will provide the continuous magnetic circuit with the minimum air gap. And figure B shows the magnetic core which is made up of the I-shaped lamination. So there are 4 I-shaped laminations which are staggered together to form one core laminations, and these laminations are assembled in proper way so that they will provide the continuous magnetic circuit without or with a minimum air gap. For small transformer, the cross section of the limb of the core can be rectangular. So this is the limb cross section which is rectangular in the nature, because the coil wound on it can also be rectangular, so we have to use the rectangular core. But friends, as the size of the transformer increases, it becomes wasteful to employ the rectangular coils, and hence circular coils are usually preferred for the winding. And under such condition, square or stepped cross sections are used for the limbs. What is limb? Limb is the portion of your core on which the windings are placed. More the number of the steps we are increasing, more circular is the cross section of the limb, and lesser is the copper required for the coil wound over it. So figure A shows the rectangular core, figure B shows the square core, figure C shows the two-step core, or it is also called as the cruciform core, and figure 3 shows the stepped core. We are using this stepping of the core. This is because the circular section has smallest perimeter for the given area. However, the saving which is effected due to the core stepping must be balanced against the increased labor charge to construct such core sections. The laminated construction and the choice of the silicon steel as magnetic material for the core help in reducing the iron loss of the transformer. So to reduce the iron loss basically consists of two components. First one is your AD current loss, and second one is your hysteresis loss. So we have seen, to reduce the AD current loss, we have used the laminated structure for the core, and to reduce the hysteresis loss, we are using the high grade silicon steel which is having high permeability and low reluctance. Then second important part of the transformer is nothing but the transformer winding. So figure shows the windings used in the transformer. The coil forming the primary and secondary windings are normally former wound using well insulated copper conductors in the form of a round wire or strips. These coils are then placed around the limbs of the magnetic core. The windings are basically insulated from each other and the core also using the cylinders of the insulating materials such as press boards or bakelite In the elementary transformer that I have explained you at the time of explaining the working principle, the primary and secondary windings are shown on the separate limbs of the core for simplicity. However, such arrangement is used in actual practice. All the flux produced by the primary winding will not link with the secondary winding, as some of the flux will leak out through the air, and such flux is called as the leakage flux. So more the value of the leakage flux, poorer is the performance of the transformer. Therefore, to reduce the leakage flux, the primary and secondary windings are placed together on the same limb in the actual practice. So these windings of the transformer can be cylindrical windings or concentric winding, and second type is nothing but your sandwich type of winding. While placing the cylindrical coil concentrically around the particular limb, the one which is designed for low voltage LV is placed near to the core. So immediately after the limb, I am placing the LV winding. So in the figure A, I have shown the cylindrical winding in the form of cylindrical in form and the concentric. So this is nothing but your LV winding, which is placed immediately after the limb of the magnetic core. The LV winding is placed after the limb portion immediately because it is always easy to insulate the LV winding. It is always easy to insulate the LV winding with respect to core as the winding voltage is less. With respect to core as the winding voltage is less. Whereas in sandwich type of winding, which is shown in figure B, the windings are divided into number of small coils, and these coils of high voltage and low voltage windings are interleaved. The top and bottom coils which are near the core are of low voltage winding. So the uppermost coil of sandwich winding and lowermost coil of the sandwich winding is always the LV winding coil. Then third important part of your transformer is nothing but the transformer tank. If the size of the transformer is small, then there is no necessity of the transformer tank. But as the size increases, the whole assembly of the magnetic core and the winding is placed in the fabricated sheet metal tank. And that assembly is immersed in the oil which is placed in the tank. This oil serves two purposes of providing the insulation as well as cooling. So transformer oil will provide two purposes. It will provide the insulation as well as it will provide the cooling to the transformer. So whatever the heat generated in the winding and the core is carried by the oil to the external surface of the tank. And also in very large transformers, cooling tubes are provided to increase the surface area of the tank for more effective cooling. Then next part is nothing but the terminal bushings. Friends, the leads of the transformers are brought out from the tank. Those are insulated from it with the help of the porcelain bushings. So these bushings are fitted to the tank. So these two are your LV bushings, and this one, those are the HV bushings. Means HV terminals are brought out with the help of the terminal bushing. So what is the use of the terminal bushing? They insulate the high voltage and low voltage conductor from the tank with the help of the porcelain bushing. Then next part is nothing but the conservator. In transformer, provision of some space above the oil level is always essential to take up the expansion and contraction of the oil with change in the temperature when your transformer is in service. So when transformer becomes warm, what will happen? Oil will get expand and the air at the top of the oil is expelled out. So when transformer cools, oil contracts and outside air is drawn into the transformer, and this process of expanding and contracting is known as breathing of the transformer. Unless the proper precautions are taken, the outside air which is entering in the transformer during the process of the breathing can have considerable moisture. When the oil in the transformer is exposed to such moist air, it readily absorbs the moisture from the air and it loses its insulating value to some extent. So this deterioration of the oil can be avoided by means of the conservator. So what is conservator? Conservator is nothing but one airtight cylindrical metal drum. Supported on the transformer tank. This drum is connected by the pipe to the transformer tank and is always partly filled with the oil. So whatever the expansion and contraction of oil will take place, that will take place in the conservator only. So the expansion and contraction of the oil in the main tank with the changes in the temperature is now taken up by the conservator tank. With this arrangement, since the main tank remains always full with the oil, the surface of the oil is not directly get exposed to the air. Then next component is the breather. So friends, the displacement of the air above the oil level in the conservator, here in the conservator during the breathing process of the transformer takes place through the apparatus which is known as the breather. Breather contains a drying agent such as calcium chloride. It contains calcium chloride or silica gel. Which extract the moisture from the air. The breather also cleans the air by removing the dust particle present in it. Thus only dry and clean air is allowed to come in contact with the oil in the transformer as well as the conservator. Means here also for the expansion and contraction process of the oil is done good by means of the breather only. The next component is nothing but, before going to explosion vent, I will explain you the Buchholz relay, because Buchholz relay is placed in between the pipe which is connecting to the transformer tank and the conservator. So Buchholz relay is a type of the protective device which is mounted in the pipeline connecting the main tank to the conservator. So this one is your Buchholz relay. Due to excessive heat developed during the fault condition, the oil in the tank in the vicinity of the fault point gets decomposed and different types of gases are liberated from it. These gases operates the Buchholz relay, which is in the initial condition only gives alarm to the operator. But if the fault developed in the transformer is converted into serious type of faults, then this relay trips off the main circuit breaker. That is the function of the breather. Means it is basically a protective device for the fault which is taking place in the transformer tank. Okay. Then last one is nothing but your explosion vent. This is the bent pipe. This one is your explosion vent. So this is a bent up pipe fitted on the upper surface of the tank. Is known as your explosion vent, or it is also called as relief valve. Relief valve. It is provided with the diaphragm which is made up of, that diaphragm is made up of glass sheet or aluminium foil or bakelite sheet. So this explosion vent is provided with the diaphragm which can be made up of your glass sheet, aluminium foil or bakelite sheet. So how it is working? In the event of fault condition, if excessive pressure is developed inside the tank, due to the liberated gases during the fault period, the diaphragm in the explosion vent bursts and releases the pressure to the outside area, thus avoiding any damage to the transformer. So this is all about the constructional features of the transformer. So let us now, in short, we will see what are the types of the transformer. So depending upon the arrangement of the core and the windings, there are three main types of the transformer. First type is core type, second type is shell type, and third type is berry type. So first of all, let us start with the core type of transformer. So here your figure A shows you the schematic diagram of the core type of transformer, and figure B shows the actual arrangement of the core type of the transformer. So friends, what are the features of your core type of transformer that we will see? Some distinguished feature of this type of transformer is that first one is the core of this type of transformer is built up of lamination to form the rectangular frame. So the rectangular frame it has, and it provides only single magnetic circuit. So the built up laminated core forming a rectangular frame, and that rectangular frame is only providing a single magnetic circuit. This one is your single magnetic circuit, means only one path for the flux. So that's why it is called as a single magnetic circuit. The windings in core type of transformer are normally cylindrical in form. This is about the windings, and they are concentric in nature. They are concentric in nature. And in this, the low voltage winding is placed near to the core. Both windings are uniformly distributed over the two limbs of the core. So in second figure B, around the limb, LV winding will be there. Then we will provide insulation after LV winding, then HV winding. So LV winding and HV winding both are uniformly distributed among the two limbs of the core type of the transformer. These windings surrounds considerable portion of the core. Since the windings are distributed on the two limbs, natural cooling is more effective in such type of transformer. So natural cooling is better, which is the next important feature of the core type of the transformer. Then maintenance is also easy for the core type of transformer. Why maintenance is easy? Because the coil can be withdrawn for the repairs just by dismantling the lamination on the top yoke. So if we will dismantle the laminations on the top portion of this transformer, then we can provide the maintenance easily. So these are the some of the important features of the core type of transformer. So it has only one single window. It means it has single magnetic circuit. The winding surrounds the core. That is the second. Then for such type of transformer, cylindrical or the windings which are concentric in nature are used, as the windings are surrounding the core or uniformly distributed over the two limbs of the core. Natural cooling is more effective in such type of transformer, and they can be provided with the easy repairs. Then second type of transformer is nothing but the shell type of transformer. Figure A shows the elementary form of the shell type of transformer, and figure B shows the actual arrangement of shell type of transformer. So now let us again see the features of shell type of transformer. Some of the specialities of shell type of transformers are: the core of this transformer provides the double magnetic circuit. The core of this type of transformer will provide the double magnetic circuit. Okay, so there are two windows. This is your window 1, this is your window 2. Two windows means double magnetic circuit. Here the windings are placed only on the middle limb, and hence whatever the total flux, that flux will get divided into two parts like this, and this is your flux path. As the total flux is getting divided into two parts, this circuit is having double magnetic circuit. The windings are normally used for shell type of transformer are sandwich type of winding. Sandwich type of winding, which always placed on the central limb only. They are placed on the central limb only. HV and LV coils, which are wound in the form of the pancakes, are interleaved from each other. The top and bottom coils which are near the yoke of the core are LV winding only, as I have told you previously. So the coils which are placing near to the core yoke portion, those are of low voltage winding only. The core nearly surrounds the winding here. So this one is the core, in the middle winding is there. In core type of transformer, your windings are surrounding the core. Here core surrounds the winding. Core surrounds the winding. This feature is useful from the point of view of providing the mechanical protection to the winding. So mechanical protection is better in case of your shell type of winding, because your windings are on the middle side, and those windings are protected by means of the core, whereas in core type of transformer your windings are on the outer side. So mechanical protection is poor in case of core type of transformer. Since the coils are placed on the central limb only, they are surrounded by the core, so natural cooling is poor in case of shell type of transformer. So natural cooling is poor in case of shell type of transformer. When the coils are to be withdrawn for repairs, a large number of laminations are to be dismantled in case of the shell type of transformer. So maintenance is somewhat hectic job. Maintenance and repair is difficult. We have to dismantle large number of laminations to provide the maintenance and repair for the shell type of transformer. Then third type of transformer is nothing but the Berry type of transformer. Figure shows the schematic diagram of Berry type of transformer. In this type of transformer, it has the distributed magnetic circuit. That is, number of independent magnetic circuit is more than 2. In core type of transformer, magnetic circuit is 1. In shell type of transformer, it is a double magnetic circuit. In Berry type of transformer, magnetic circuits are more than 2. So, the core is constructed in Berry type of transformer in such a fashion that its yoke radiates out from the center just like spoke of a wheel. So, rest of the features are similar to that of your shell type of transformer in case of this type. Okay. So, this is all about the types of the transformer. So, in my second lecture, students, I am going to cover the EMF equation of the transformer. Then, what do you mean by the voltage, current, ratios of the transformer, transformation ratio, and how the transformers are rated. Okay, so thank you for your listening. If you like the video, don't forget to like, share and subscribe this video. Thank you.